Dear colleagues and friends, welcome to my presentation that is the use of RNA ALAS2 biomarker in DBS to detect rhEPO microdoses. Actually, the principal marker of a hematological module of the athlete biological passport are hemoglobin and reticulocyte. However, these two markers have some difficulties to detect doping with microdoses of EPO. For this reason, new biomarkers could help us to detect this kind of doping. Previous studies have illustrated that transcriptomic biomarker, and in particular, RNA from reticulocyte could be an interesting marker to detect blood manipulation, particularly the RNA from the gene ALAS2. ALAS2 is a protein directly involved in NDO synthesis. Moreover, previous studies have illustrated variation of ALAS2 could be measured after administration of rhEPO using DBSs as matrix. Dry blood spots could provide many advantages for anti-doping analyses, like minimal invasiveness, easier collection of samples, easier transport and storage, and a longer stability. Thus, the aim of the project are the monitoring of red RNA-based biomarker after rhEPO microdoses administration. The monitoring of red RNA-based biomarker under hypoxic condition. In fact, athletes used to live and train in altitude, and this could have an impact on blood markers and be an important confounding factors. And finally, the analysis of the red RNA-based biomarker using DBS as matrix. For this project, we use samples from two different clinical studies. The first one regarding microdoses has been done at anti-doping lab in Salt Lake City. In this study, 21 all-female volunteers have been separated in two groups, treated and placebo. Volunteer and treated groups received 6 microdoses of 900 units of EPO along 12 days. The second studies have been performed at anti-doping lab in Qatar, in Doha, regarding hypoxia. Here, 10 volunteers have been separated in two groups, altitude and control. Participants from altitude groups stay 6 hours during the day in simulation room with a simulated altitude up to 5,400 meters, and 10 hours during the night in the same room with a simulation of the altitude up to 3,000 meters. Volunteer and control groups stayed the same time in the hypoxic room with a simulation of the altitude up to 250 meters. To perform analysis, we extract RNA from DBS with first incubation time and acidification period. Then we pass our solution through a column from RNase kit from Kagen. And then we reverse transcript our RNA in cDNA to analyze our gene by RT-qPCR. The result obtained from microdoses studies have been reported in percentage of the baseline. This line indicates the day with an EPO administration. We can observe a significant effect of microdoses on the expression of ALAS2 in the treated group. There is a significant differences between the two groups. In fact, control groups' variation of ALAS2 are not significant. Regarding hypoxia condition, in this case, any significant differences between altitude and control group of for ALAS2 expression have been noticed, which is not the case in reticulocyte site, where there is a significant variation between the two groups. Finally, the result confirmed that RNA are stable in DBS. Samples have been collected in 2019 from the Salt Lake studies and in 2017 from the Doha studies. All the samples have traveled and have been stored at room temperature. To conclude, this study has demonstrated that microdoses have a significant effect on ALAS2, which is not the case for actual marker of the passport. Moreover, it has been demonstrated that red direct to altitude, which is not the case, which could induce false suspicion on a sample. This is not the case for ALAS2 RNA. Thus, we demonstrate that ALAS2 red RNA-based biomarker could help for improving specificity and sensitivity of the passport. They are compatible with DBSs. The limitation of this study is that only male volunteers have participated to both studies, and a very high degree of hypoxia have been simulated in simulation group. In hypoxic group, sorry. Thus, for the future, it will be important to monitor red RNA markers in women and test natural hypoxic condition. Also, it will be important to test the combined effect of altitude and MPO on red RNA markers. And finally, test other type of marker on DBS like hemoglobin. This could allow us to create an alternative of scores between ALAS2 and hemoglobin, for example, which could be used to confirm a suspicious case on a passport or to perform an analysis long time after correction. Finally, I will thank PCC for their contribution on this project and for the ongoing one, and also the WADA that contribute also to the ongoing project. Thank you for your attention.